this keyword. The single JavaScript concept that breaks more Lightning Web Component code than anything else, and almost nobody explains the actual rule behind it. That changes today. Here's the big idea before we touch this directly. Every Lightning Web Component you'll ever write sits on top of plain JavaScript. Your @track properties, your handle click methods, your imperative Apex calls. None of it is Lightning-specific magic. It's JavaScript running inside a component wrapper. If the JavaScript underneath is shaky, everything built on top of it is shaky too. Let's start with the basics. 3 ways to declare a variable: var, let, and constant. Let and const are block scoped. They only exist inside the curly braces they're declared in. Var is function scoped, and it leaks outside blocks in ways that cause quiet bugs. In modern JavaScript, and in every LWC you'll write, use const by default and let only when a value actually needs to change. Look at this leak. Inside an if block, var actually escapes and is still readable outside it. That shouldn't work, but it does. Let and const stay exactly where you put them. Try to read a let declared variable outside its block, and you get a clean reference error instead of a silent bug 3 files away. Now, 2 ways to write a function: a regular function declaration and an arrow function. Both run code. Both can return a value. The difference that actually matters for Lightning Web Components isn't the syntax. It's how each one treats the this keyword, which is the entire point of this session. Here's the syntax side by side. A regular function declaration. An arrow function doing the exact same job, assigned to a constant. And the shorthand version, for a single expression, without even needing curly braces or a return keyword. So what is this actually? It refers to whatever object is currently in charge of running the function. Here's the part almost nobody explains clearly. This is not decided by where you write the function. It's decided by how the function gets called, what's known as the call site. Watch this. Same describe function, defined once inside a car object. Call it as car.describe. This.brand correctly logs Toyota because it was called on car. Now assign that exact same function to a plain variable and call it alone. This.brand is undefined. Nothing about the function changed. Only how it was called changed. That's the rule. Call site, not definition site. Same function, same code, 2 completely different results, because it was called 2 different ways. This single fact explains almost every related bug you will ever hit in Lightning Web Components. 3 call patterns, 3 different outcomes. Call a plain function directly. This is undefined in strict mode. Call that same function as a method on an object. This becomes that object. Use .bind to explicitly lock this to an object. Now it's guaranteed, no matter how it gets called afterward. Gotcha number 1, straight from real LWC code. You write handle click event and expect this inside it to be your component. It usually is. LWC binds your handler methods for you automatically. But the moment you pull that method out as a bare reference and hand it somewhere else, that guarantee disappears. Here's exactly how that breaks. Inside the class, this.handleClick works fine when called as this.handleClick. But extract it, const handler equals this.handleClick, and pass that bare reference into add-event-listener, and this inside handleClick is no longer your component. It's whatever called the function this time. Gotcha number 2. setTimeout, promise.then, array callbacks like .map, any regular function you pass into one of these runs with its own this, not the surrounding components this. This is, hands down, the single most common source of this.value is undefined errors in Lightning Web Components. Here's that bug in code. A class with a value property set on the component. Call setTimeout with a regular function inside load data, and inside that function, this.value logs undefined. This inside a regular function passed to setTimeout is not the class instance anymore. Here's the fix, and it's the single most useful fact in this whole session. Arrow functions don't create their own this. They borrow it from the enclosing scope at the moment they're written, not the moment they're called. That one property fixes both gotchas you just saw. Same broken example, one change. Swap the regular function for an arrow function inside setTimeout. Now this.value correctly logs set on the component. Because the arrow function inherited this from load data scope, where this was already the class instance. Sometimes you can't rewrite something as an arrow function. Say, you're handing a method reference into third-party code that calls it for you. That's where manual binding comes in. .bind returns a brand new function permanently locked to a given this. .call and .apply invoke a function immediately with a given this, useful for one-off calls. Here's the classic LWC safe pattern. Inside the constructor, rebind this handle click to itself using .bind this. From that point on, no matter how or where handle click gets called or passed around, this.value inside it is permanently locked to the component instance. 3 ways to control this. Arrow functions, when you're writing new code. .bind, when you need to hand a method reference somewhere else safely. And simply knowing your call site, so you can predict what this will be before you even run the code. Master these 3 and related bugs mostly stop happening. Recognize the call site, control the bug. Every session after this one, component communication, wire adapters, imperative apex, assumes you've got this down. Full code, every example from this session, written out on realsyllabus.com.